So today's training is going to be about virtualization primarily. We'll also touch a little bit about the concept of containers and how they relate to each other. But primarily, I just wanted to take a chance and have a video introducing the concepts of virtualization and a little bit about interacting with some of the common platforms there are for running virtualization. So we're going to go through that now. So understanding virtualization, again, why virtualize, what are the key platforms, understanding containers. Containers we're going to touch upon lightly in the interest of time, but they're also a very, not just up and coming technology, but there's a lot of advantages to moving towards containers, and they're really exploding on the backend side. A lot of the cloud is using containers in addition to virtualization. And we're just going to talk about some of the reasons why people embrace this technology so much. So virtualization, what we'll see here on this slide is, a lot of the advantages and what sort of virtualization is. Essentially, you'll have a platform. You'll have what's called as a hypervisor. The hypervisor comes in many shapes and sizes. The traditional hypervisor was mostly deployed on dedicated technology like servers. It is a way in which the system itself can sort of extrapolate between interacting with the hardware and then presenting pieces of that hardware, at a per core or per thread basis on the CPU, at however much memory you want to allocate to a VM, how much disk space you want to give it. All of that gets extrapolated by the hypervisor, which then aggregates those loads as sort of image files, which then run off the server itself. The hypervisor is this extrapolation layer, is essentially itself running on an operating system, generally of a Linux or FreeBSD variety. There are exceptions. VMware sort of has its own kernel, but is also based upon a Unix POSIX backend. The the VMs themselves can be pretty much any operating system you want. So on top of the virtual machine, so long as the hypervisor supports that particular VM or that particular operating system, you could have Linux machines, you could have Windows machines, you could have FreeBSD, you could have even Mac OS for certain hypervisors like VMware. And you can increase the density and essentially the bang for your buck for a lot of your physical servers. So when we're looking at the advantages of hypervisors and virtualization, there's many advantages. These are probably just the top five. So you have, again, better density, more machines per physical machine. Each operating system can be better isolated. So if you originally were purposing, say, a physical server and you want to run everything from your web server like Apache or Nginx, and you also wanted to run your database, and maybe you have some other monitoring tools. Traditionally, many years ago now, not even traditional anymore, but you would have to put all those services into a single server, and if that server goes down, everything goes down. Or you have multiple servers, so you have to buy lots of hardware to spread them out. With the hypervisor, you can spread them out with virtual machines so that, from a security standpoint, maybe I'm only letting my web server have allow external connections, and then on the back end, it's via an internal IP to say the database. I know this is getting a little bit complicated, but from a security standpoint, extrapolating the systems, making sure that there's no single point of failure, it's much easier to do on a virtual machine. The fact that you can run more operating systems on a single server means that the memory usage, the CPU usage, and the networking can stay at a higher point at any given time. Say, for example, you were using a web server. You might not be running that web server at 100% all the time. It depends on who's accessing the website. Well, that server hardware, if it was just a single server, you wouldn't be getting the best bang for your buck for providing all of those hardware components. On desktop computers, on laptops, because it's your personal PC, the workload itself is very bursty to begin with. You're using the content to burst in when you're playing a game, or when you're streaming video, or when you're on YouTube or Netflix or whatever. You want to always have a little bit of bandwidth for that bursty kind of workload. On a server, that's not necessarily the case. On a server, you want to have nice, even runs. You want to be able to make use of the hardware that you provision the server to. And maybe there would be certain workloads where you are a little bit bursty and you allocate within that. Servers are very expensive systems. They have lots of memory, they have lots of CPU power. You'll often have somewhere between 40 to 60 threads, if not more, on a single server box these days. You'll have hundreds of gigabytes of memory. There's a reason for that. And the best way to make use of that, because it's, the base unit cost for a server motherboard and the power supply and all that is a fixed cost. And if you get a bigger system and you deploy virtualization, you're getting a much better bang for your buck, much better usage from the system. You're also going to have quicker deployment because virtual machines, everything is essentially a virtual machine file, a VMDK on VMware or uh, QCOW2 on KVM or OVA on VirtualBox, etc. You'll have these little image files, and I'll show an example of that in a minute. And you just start the VM and it will start right up. It also makes for reprovisioning. So once you have this hypervisor set up, so long as you have another system where you install that hypervisor, you can just essentially copy those image files as long as they're powered off. You can clone the image files or copy them or whatever, put them on the second system, start them back up, and you're pretty much good to go. All your virtual machines, all your initial workload is immediately transitioned from one system to another system. You don't have to reinstall all the services. You don't have to do anything like that. The data itself is also persistent as long as that data resides in those virtual machines. So there's a huge advantage for having this kind of setup for just standard workloads, provisioning, and the last one is better disaster recovery. Again, because you're working off of images, you're not working off of physical servers and things that are deployed on bare metal hardware. Um, from the backend side, what that does is when you're deploying on a bare metal hardware, the storage and the mount points for all of the things that the operating system does, it'll look exactly at the physical hard drives. So when you try to migrate that, you have to use a lot of special software to like clone or re-image or do things like this to get data off of those drives and then be able to move it somewhere else. With the VM, because the underlying layer where the operating system was installed is on the hypervisor. So long as you have a homogeneous hypervisor, it's very easy to migrate these virtual machines so long as you stay consistent with your hypervisor of choice. So you can take the files, migrate them, provision them up and down, and you can also do HA. That's another feature for a lot of enterprise grade hypervisors where you'll have failover. If the physical server goes down, the second server will take those VMs and restart them automatically, and that's very commonly used. And being able to do HA from a physical machine is essentially impossible because if the physical hardware goes down, the physical hardware goes down. And unless you have like some constant sync between data, it's nearly impossible to do this sort of HA provisioning. So you get a lot more ease of management. You get better use of your hardware. You get you lower your operating costs because you're using less hardware to do the same workloads. Better security, better uptime. There's just no reason these days not to go virtual for pretty much every single task. Here's an example of virtualization. So I just have a couple of screenshots. This is using Virtual Machine Manager. It's the open source Virtual Machine Manager, which gets used with Linux, and you can map it with KVM, which is the Linux version of a hypervisor. It's the sort of the kernel approved or what's this default standard is. There's many other hypervisors like there's VMware ESXi, there's Zen and Zen Server. This is mostly developed by Citrix, and they're still very big, particularly in the virtual desktop space, VDI. KVM, like sort of what we're showing right here, and then the Windows has its own hypervisor called Windows Hyper-V. Okay. So we'll just run through a quick demo. This is going to be just a quick overview of the interface of VMware ESXi. So let's jump over to that. So when you first get to the VMware, this is running on a separate system. In VMware, you log in to the management console. They have a management console which they give you at an IP address. So inside this IP address, you'd be able to go in, you enter root, the password, And once you're inside the interface, VMware runs everything in this web interface, so you interact entirely with the interface on the web. There are other interfaces which also come at a premium. There'll be things like vCenter, which allows you to manage multiple virtual hosts and is better for the enterprise stack. This is the default UI, which comes with a vSphere or ESXi implementation. ESXi is their hypervisor, but it's also they have a free tier, which is what I'm running right now. So you can see here, you'll be able to go in, you can create or register the VM, you can sort of run through the UI, you can deploy a virtual machine from a separate kind of file, you can register a virtual machine, create a new virtual machine. Going through the UI, it'll just ask you, like, you give it a name, say this is test Linux. You'd be able to pick which level of hypervisor you need the compatibility with. I'll just go with the newest. The guest operating system, we picked Linux. There are other ones you can choose as well. And then we can pick which OS version of Linux this would be, and they have a huge list. Let's pretend we're using Red Hat. Then you can get some data store. So obviously this is way too small for a standard implementation, but if we had additional data stores, we could mount them over here. So I'm just going to sort of show you where that is. On the storage side, you can set new data stores. So you can create a VMFS data store. You can mount an NFS point. So if you're using, if you remember back from the storage and the server overview, we talked about things like setting up SMB and setting up these shared file systems. VMware can use NFS. It can also use, if you add an extent, this is where you would set iSCSI. If you wanted to do a block level storage, you would set up over here. But essentially, I just wanted to sort of give an overview of what the UI looks like. This particular virtual machine and what this system isn't actually going to run. This VMware ESXi is just for demo purposes. Now going back here, we also have another example which should be a little bit more interactive. So the other hypervisor choice, particularly if you're working off, say, like a workstation or like a desktop interface, there's probably three kinds of hypervisors which would sort of be of choice. Oh, and I forgot to mention one thing. On the VMware, Red Hat Enterprise Virtualization, Zen Server, these are what are known as bare metal. So I forgot to mention the title of the slide. But bare metal hypervisors, what they are is essentially the operating system is very stripped down. It's primarily installed just to run the what would be, you'd have a web server here, which is allowing us to interact with the ESXi web interface, but it's primarily running the hypervisor. It only runs, the hypervisor essentially, and then everything else that you want to do on the operating system has to be done in the virtual machines. So when we're looking at the boot screen, and what you would see here in ESXi is all you can see from the window when you open it. There's no buttons that you can click. All you see is this, and it tells you, this is the IP address at which you can access this VMware ESXi interface on. That's it. So it's designed only to act as the host and host the virtual machines. The other kind of virtualization, which is, I think in the code is not all that much different, but essentially it is installing a hypervisor in addition to the desktop workload or the other sort of services that you might be running on your system. And there's several examples. There's with Windows 10 Pro, you can use Hyper-V. Hyper-V you can also use on Windows Server. Windows Server itself isn't really bare metal in my opinion, even though it has, it can perform very well, but it's Windows always has a UI component to it, so even on Windows Server you still have a UI. So it's, it has those UI elements which would still be running in the background, but Hyper-V is a valid option. And with Windows 10 Pro, you have the option of running Hyper-V natively on the Windows 10 system itself. If you have Linux KVM, for desktops, this would be, there's a hypervisor flavor called Kimu, and I'll show this in just a moment. And then one system which is good, and a lot of people use it for testing and things like that, is Oracle VirtualBox. And the nice thing about VirtualBox is it's cross-platform. So it's not open source, but it is uh, a freeware. So it's a free tool which you can install. It's managed by Oracle, and it lets you set up virtual machines in much the same way that, say, Virtual Manager allows you to set up the virtual machines. I have used it. I tend to end up having to use it for Windows because I often don't have the Windows 10 Pro. I might have Windows 10 Home, so I can't use Hyper-V. But with VirtualBox, you can run it on Linux, Mac OS, or Windows. So it's a good thing. It's a good tool to have. What we have here is the uh, QEMU running with Virtual Machine Manager. Virtual Machine Manager is essentially the UI component. And I show here the install command. This would be for Ubuntu. Sudo apt-get install. Actually, I should just say sudo apt install. Sudo apt get install or sudo apt install QEMU kvm, QEMU utils, libvirt daemon system, libvirt clients, bridge utils, virt manager. Virt manager is this UI component here. All the rest of this is libraries that you need to install, and then the QEMU kvm pages so that it knows we're running this virtual machine. That should be it. Occasionally, depending on what version of Linux you're using or what version of Ubuntu you're using, because there are many different flavors, you may or may not need to install additional resources to bring it up and running. But let's sort of break out and have a look at this. So this system that I'm running right here, this Linux Mint box, which we started with the first video, this is actually a virtual machine. So let's leave this, close, close. And you can see here, this is my main desktop computer. I have a couple virtual machines running on this. Virtual machines are very memory intensive, so you can see here with 3 virtual machines, I'm running around 10 gigs of RAM. So I'm fortunate enough to have 16 gigs on my desktop. But if you have the memory to do it, you essentially would be able to go in. We can inside of this, so you can see this is the preview image of what we were working off of, but we can also go into the management. You can see this is the Linux Mint 19 version 2. It shows you have the boot options, you have uh, the networking options. You can set this if you want it to be an NAT. None of these things, if you have the ability to pass through like a bridge, this is where the bridge utils comes in. You can set this and change it, but you won't be able to change it until you actually power off the virtual machine and repower it on. So we're not going to change anything right now. You can add hardware. This would be virtual hardware. You can set how much memory you want. Um, Over here, you'll see how much CPU resources you have. When it talks about the number of CPUs, it actually talks about threads, not cores, not physical processors. It talks about threads. And this is also what you would see in the system monitor. So you see I have 4 threads on my desktop because it's a dual core CPU with hyperthreading. So it has 4 threads. And yeah, once you have the system set up, creating a new virtual machine is really quite easy. You can just click this little wizard. You say, do you want to import an image or do a network boot or something? I think for most people first starting out, you would just have like the ISO image. This would be the ISO that you download like of your Linux distribution. You go forward, you can just browse for what images you need. So say we're in downloads, we might have, where would it be? So browse local, then you can sort of pick which image you would have. So I have a lot of images over here. Maybe we want to install Manjaro or something, or Zorin OS. You would just pick the ISO, then go forward. It'll ask you how much memory, how many CPUs you want to go give it. You can set how much disk space you want to give it for the image file. That disk space will get used. It may not get used right away when using QEMU KVM, but this is sort of the max amount of space that the file can reach. And when you first provision it and you install the operating system, yes, it will take up a lot of this space. So you do need to have, if you want to run virtual machines, you do need to have a lot of hardware components. Robust hardware is going to be key. Lots of memory, a pretty good number of threads. Although Chemo KVM allows you to do what's called sort of over provision, or sort of you can allocate more CPU threads than you actually have, and then it runs sort of sequentially so that whatever is getting the most priority on your CPU sort of bumps up and down. The management of that's pretty intelligent, but you don't want to say, oh, I have 60 virtual machines running at the same time on like a dual core CPU. That's just not going to work. You need to try to have an equal number of threads versus the number of CPU virtual machines that you're running at any given time. Otherwise, you'll run into serious issues like system lockup and things like that. So, going back to the presentation, and again, all I did there was this this presentation is running on a virtual machine, so it's running within a web browser on a virtual desktop. And I just you can exit out of it just by going to the top middle, and then once you go full screen, then essentially you're in a whole other world. Essentially a lockdown environment, separate environment from your desktop. The last slide and the last thing I wanted to touch upon is virtualization. So there's a lot of, oh, not virtualization, I'm sorry, containers. Containers are robust tools which in many ways are replacing virtualization. And this is an image which I just took from Docker's website. Hopefully they don't mind because I'm promoting their tools, but Docker is an amazing tool set. There's other ways of running containers, Linux containers, coming out there. OpenShift from Red Hat is sort of an enterprise version of that. There's something called Kubernetes. You may or may not have heard about that. Kubernetes is essentially orchestration. It's a way of more intelligently provisioning and managing and hosting multiple containers, and it scales to a couple of containers to thousands of containers to tens of thousands of containers. It's an extremely powerful tool. OpenShift is the enterprise version of that from Red Hat. And in terms of the containerization technology, how you create the containers, Docker is undoubtedly the king. At least the community edition of Docker is. And what Docker does versus the traditional hypervisor, which we just talked about, is in the traditional hypervisor host system. Remember, I said that virtualization is very resource intensive, and the reason being is every time you deploy a new virtual machine, you're running an entire operating system underneath it. You have the guest operating system, and you have the kernel essentially. These kernels, have a lot of overhead to them. It has to run whatever processes that the host operating system deems is necessary for that operating system to run. Now you can sort of subtract that. You can, especially in Linux, you don't have to run everything. You could just, maybe forego having a desktop and do everything from the command line, but you still have that kernel component. With Docker and Podman, this is the Podman, these C's or otters or something. I'm not sure what they are. Anyways, for Docker, the applications essentially leverage the host operating system kernel, provided the host operating system is Linux. With Docker, you install the Docker packages, and then you launch what's called a Linux namespace. You put things into a local namespace that's separate, and it only runs the components of the operating system or the services that you want to run and what the services that also need. So it might have some underlying libraries. If you're running specific applications, it might have some underlying host images that you need to pull from. In Docker, when you set up Docker and you do a pull, it'll pull down an image from like the Docker Hub or something, another third-party image store, which has all the components that you need for that particular image. Then you can also interact with the image. You can run it. You can run data on it. So, for example, when I do web development, if I want to run just a test environment, I can run 3 Docker containers, and essentially have maybe a few hundred megabytes of overhead running these Docker containers, and I'm running. I have my Apache server going. I have my MySQL database going. I have phpMyAdmin going. I have all these other services which I would need. If I put them in a virtual machine or several virtual machines, I would need a ton of RAM. But in Docker, I'm just using, a few hundred megabytes, maybe a gigabyte of extra RAM, as opposed to, say, 6 gigabytes if I wanted to run those in 3 different virtual machines. And it could be even higher depending on what operating system you run. So Docker has a huge advantage in terms of the speed at which you can launch it. The manageability is very good if you get very familiar with the interface. I personally think virtual machines are probably a little bit better if you really need to isolate something because it's a completely separate container. It's a completely separate operating system. It's not in a single container leveraging the host resources of an operating system. Um, but Docker has its place, and if you wanted to split down services into individual components, but essentially what you're running is a single service application. Like I'm running a single web server, so I could have my web server. It's in a virtual machine. My virtual machine is set up with HA. Inside the virtual machine, to save on resources, I run Docker, so that my Apache web server, my MySQL database, my phpMyAdmin, my email server, whatever that's running on that particular virtual machine, I can isolate that down further using Docker, using Podman, using these container technologies. Um, so again, we're a little bit out of time for the purposes of this video to really go in deep dive in containers. I myself am probably not the best person to talk in deep about containers, but I will put more links in the blog post about some more information and also some other good, maybe some good YouTube videos about people doing a fair explanation of what Docker is and some of the in-depth usage cases. But I want to, juxtapose the container technology with the virtual machine technology so that you have a good idea and a good understanding of, where the two relate and how they get used together. So with that, still more videos to come. Sorry the cadence is a little bit slow these days, but thank you very much for your time.